Okay, things are gonna get fast because we're talking about catalysts. I'm Jono from Seneca. It's another revision episode going over GCSE chemistry, and we're talking about catalysts. They're a really important topic, and they're also really important in the real world and chemical industry. So they're a good thing to understand and wrap your head around. So let's get into it. Before we talk about catalysts, we need to talk about rates of reaction and the key factors that affect a rate of reaction. And there are 5 things that are really important to consider. Firstly is the concentration of reactants. More reactants means faster rate, right? It makes sense. If you've got more of something, the rate's going to be faster. If it's a gas, it's about the pressure of the gas reaction. And increasing pressure is like increasing concentration because it mashes everything closer together and the gas particles are more likely to collide, so there are more successful collisions. If you want to review successful collisions, make sure you check out the episode on chemical reactions and collisions. That will go over a lot of the key terminology used here. Another important factor for rates of reaction is temperature, because increasing temperature increases the number of successful collisions. So there is a greater rate of reaction. Surface area. Surface area is really, really important because increasing the surface area increases the frequency of collisions. And this obviously increases the rate of reaction. So this is often done by breaking up bigger solids into smaller parts. So rather than having a lump of sugar, you would have granulated sugar. Because it increases the surface area to volume ratio, so more of the molecule is exposed to the outside and other reactants. And finally, I'm sure you're not expecting this, catalysts. That's another really important factor for rates of reaction, and that's what we're going to be talking about a lot in this session. So just to recap, 5 key things that affect the rate of reaction: surface area, concentration, and pressure, and temperature and catalysts. Just to quickly explain surface area, basically increasing the surface area increases the amount of reactants that are exposed for reactions. So if we have a square that's 2 centimeters by 2 centimeters by 2 centimeters, it's going to have a volume of 8. But if we take that same square and we cut it into 1 centimeter cubes, so 1 centimeter by 1 centimeter by 1 centimeter, a lot more surface area is exposed. So that's going to give a faster rate of reaction. Okay, now let's get into the meat of it, catalysts. Catalysts increase the rate of chemical reactions critically by lowering the activation energy. And it does this by providing a different pathway for the reaction to follow. So catalysts, they're not used up, so they can be reused again and again and again. And we don't include the catalyst in the chemical equation because overall it's unchanged. It might change a little bit in the reaction, but by the end it's going to be the same. But they do need to be cleaned or regenerated, which can have a kind of a knock-on effect in industry and environmental impact. Different reactions require different catalysts. So some good examples are iron is used to make ammonia, platinum and palladium are used in cars, catalytic converters, and enzymes are biological catalysts. Like we were talking about with surface area, catalysts are also, we want to give them the bigger surface area that we can. So they often come as powders or pellets or fine gauzes because they've got a high surface area. And if we think about reaction diagrams, remember a catalyst is going to decrease the activation energy. So the line between the reactants and products is going to have a lower height. And how do catalysts work again? Lowering the activation energy. Okay, so catalysts, important in chemistry, but also really important in industry. They are super cost effective. Even though they're sometimes just super precious metals like platinum, they can be reused and normally it's only a small quantity required. So paying for a catalyst can be cheaper than paying for the energy required to increase the rate by increasing temperature or pressure. They also reduce the burning of fossil fuels because they can reduce the temperature and pressures required for reactions to occur. However, they can be a little bit toxic. A lot of them are transition metals, and they can escape into the environment and contaminate ecosystems. So that's an important disadvantage to remember. But do you remember the 2 advantages? Cost effective and reduce burning of fossil fuels. Awesome. So let's go over an example. Let's talk about acid rain, okay? So limestone and marble can crumble when they react with acid wet rain. If we increase the concentration of acid in rainwater, at what rate will the limestone and marble decay? Will it be faster or slower? It's going to be faster. There's going to be an increased rate, okay? Because there's a greater concentration of acid, so the rate of reaction is going to be faster. Okay, so key things that describe catalysts. They lower the activation energy. We don't put them in the chemical equation. They're not used up in the reaction, but they increase the rate of reaction. So those are the 4 key points that I would make sure you really understand about catalysts, okay? And they're often cost effective, even if they're made of expensive metals like platinum. Right, so let's review quickly. What are the effects of increasing temperature on a chemical reaction? Is it going to increase or decrease the rate? Increasing the temperature increases the rate because there's more frequent collisions and there's increased energy of the reactant particles. So that concludes the lesson on catalysts. I hope that was a useful review. Let me know what you think, and I hope to catch you in another episode. Thanks.